So good evening to all. We were discussing about forces, I think. So which force we have covered?
Third, endogenic, exogenic, both are covered.
So we talked about. So mountain building force we have to start, no?
Yes, sir.
एक बार जरा बोलें तो आवाज बहुत धीमी आती है आपकी. मैक्सिमम
Yes,
है.
sir.
हाँ, अभी आप आवाज सही आई. So let's begin. Let me share the notes first. So we were discussing about the forces. And the next is mountain building force. So we are going to discuss about mountain building force. Building force. Yesterday I forget to share the notes. Today I will share it. Okay. So orogenic. Or sometimes it is also referred as orogenetic force. It is of two types. One is compression. Compression that results folding and faulting both. While tension, due to tension, there is formation of fault only. So there is faulting that is done. So let's take up one by one. Compression. So what happened when the crustal rock feel a force, and that too tangential to each other. The force is a tangential force, and both are acting towards each other, F1 and F2. So it intended to cross folds. So there is formation of fold, and the crustal rock get bent in this type of anticline and syncline. So this is upfold, that is called as anticline, and downfold, that is called as syncline. Anticline and syncline. Anticline as well as syncline. So both the forces are acting like this, F1 and F2. Here the upfold, this is upfold, and here it is the down. Downfold is called as syncline, and upfold is called as anti. And in this way, we happen to have series of folded mount. Series of folded mount. Folded mountain. Where anticline represent mountain ranges. While syncline represent either it is valley or broad valley, sometimes referred as dunes. Fine. So we have folding, and different types of folds are formed. So we have different types of fold. Types of fold. Number one, there is symmetrical fold. Symmetrical fold, in which, although in nature it is not possible to have this symmetrical fold, so it's a simple fold. When both the when both the arm of the fold is what? Equal. There is equal size of the arm, there is equal slope of the fold. Okay. You will find that the medial line is actually dividing the fold into two equal parts. So this is what medial axis. Medial axis that divide the fold into equal parts. So both the arms are equal, equal in terms of slope. Slope is equal, and both the arms are equal. Both the limbs has means similar gradient. Then we call it symmetrical slope. Symmetrical fold. And symmetrical fold are very rare in nature. Very rare in nature. Because symmetrical fold can only be possible when both the compressional force are equal. Force are equal. And not only this, it is not only force which is decisive, but also the nature of the rock. Nature of the crustal rock. Crustal rock must be same. Must be same. And this is not going to be the case. There will be certain difference. And due to that, in most of the time, we are not going to have symmetrical fold, rather we have asymmetrical. Okay. So symmetrical fold are very rarely found in the nature. It's a rare, both very rare in nature. So this is what symmetrical fold, both the fold means medial axis divide both the fold into two equal parts. Let's talk about asymmetrical fold. Asymmetrical fold. And in nature, we happen to have this asymmetrical fold. Unequal and irregular limbs. Unequal and irregular fold arms. Fold arms, that is also called as limbs. Unequal arms. The inclination of both the limb, inclination, that is what gradient of both the limbs. Both the limbs are unequal. Okay. So this is what asymmetrical fold. Asymmetrical fold. An asymmetrical fold is of many types, like first one is monoclinal fold. तो asymmetrical fold आप समझ पा रहे होंगे बच्चे, symmetry will not be there. Like this is the fold. So this is the medial axis. Medial axis, and there is a folding arm A1. Here it is A2. Try to see the slope. Try to see the slope. Fine. This is what asymmetrical slope. What do you mean by monoclinal slope? Monoclinal slope. One of the arm has a right angle slope with the crustal rock. So this is how the slope has been done. Means folding has been done, and the slope is making a right angle with the crustal. So this is the crustal rock. This is the crustal rock. Crustal rock. Here, try to see the slope, gentle slope. And this is first arm. Here it is the medial axis. Here A1 and A2. And this angle is 90 degree. One of the fold is making 90-degree angle with the crustal rock. Here, the fold is called as monoclinal fold. So you can write one of the limb is making 90-degree angle with the crustal rock. Crustal rock. Such fold, such folds are termed monoclinal. 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 Then there is isoclinal fold. Isoclinal. So in isoclinal fold, both the forces are so strong that both the arm remain parallel with each other. They remain parallel with each other. Like this. So they remain parallel with each other. This is the arm 1. Here it is the arm 2. A1 and A2. This is the arm which remain parallel with each other, but not being horizontal with the crustal rock. Then such folding is called as isoclinal. Isoclinal. Here we have isoclinal fold. So these are the crustal rock. And you can see that one of the slope is like this, and the slope is making less than 90-degree angle, and both the arm A1 and A2 remain parallel with each other. Such folds are called as isoclinal fold. And do remember, both the arms remain parallel, but not horizontal. Not horizontal. Both the arm remain parallel but not horizontal. अगर horizontal हो जाएंगे तो वो fold हो जाता है बच्चे recumbent fold. ठीक है, it will be recumbent fold. So isoclinal fold. Next fold, asymmetrical fold is, that is recumbent fold. Recumbent fold. Recumbent fold. So in this case, both the limbs become parallel and it also become horizontal. Both the limbs become parallel and also become horizontal with the crustal. Both the limbs become parallel as well as horizontal with the crustal rod. So this is crustal rock. Here we have the arm 1, A1. This is A2. Both the folds remain parallel as well as parallel with the crustal rock. Then we call it a recumbent fold. Okay, both the limb become parallel as well as horizontally parallel. Then it is called as recumbent fold. Okay. Then what happened when this folding is taking place? Suppose that this folding taking place, especially the isoclinal fold to recumbent fold. So in the process of folding, what happened? The crustal rock, the upper part of fold is what? Pulled by gravity. So gravity will cause fault development over here, and the folding is going on, like F1 and F2 forces are there, and due to this fault, this particular upper part get detached from the fold and fall away from the folded, what you can say, range, mountain, and for several kilometers, means it move for 5 to 10 kilometers away from the mountain range. This detached part is called as nape. Nape. So how nape was formed? This nape was formed because of complex folding. And when this folding is going on, the upper part get, what you can say, detached because of the thrust. The upper part get detached and it start rolling down the hill and reaching for 4, 5 to 10 kilometers away from the foothill of mountain, and that we call nape, where you will find folded rock. Okay, so please take down nape. Nape. It is a result of complex folding mechanism. complex folding mechanism in which upper part of the fold, upper part of the fold get thrusted away and detached from the parent fold and moved down the hill and moved down the hill. This is called as this detached topography, this detached topographical feature is called as nappe. Is called as nappe. इसे nappe कहते हैं बच्चे, ग्रीवा खंड कहते हैं, ग्रीवा खंड. फोल्डेड माउंटेन की गर्दन कट के दूर चली गई. So several examples of nappe you will find in folded mountain series, like near Alps mountain, several kilometers from the foothill, we have so many nappe. Okay. So there are many nappe in Alps. You will find nappe in Pennine also. Pennine, Dinaric Alps nappe. Dinaric Alps nappe. Okay. Dinaric Alps nappe. Fine. So this is the folding and the formation of fold mountain takes place. Let's come to the faults. Faults. So we have several types of fault. Let's take up first one, that is what? Normal fault. Normal fault. So normal fault is due to tensional force. Suppose that this is the crust and tensional force T1 and tensional force, let's say T2. Both are acting on this very crust in opposite direction. So when there is a tangential force acting opposite direction, we call it tension. Tension, right? Again, another tangential force. So due to tension, these crust develops a fracture. Okay, crack, this crack transform into fracture, and the fracture ultimately transform into fault. So there is a fault, and here it is block A, and this is block B. This is the meeting point of these two blocks. Now what happened? Along this fault line, there is a movement of the block, and if the movement is like this, block A is moving away from block B. So here it is the block B that moved away like this. This is block B. Block A, earlier it was here, now it is here. So try to see, it is moving away from A. So block A is moving away from block B. The movement is like this. And here it is going to be the horst, and this is going to be the graben. Fine. And such faults are called as normal fault. So normal fault is of the type when both the blocks, when both the blocks are moving away, away from each other, each other along the fault line. When both the blocks are moving away from each other along the fault line, then we call it normal fault. Normal fault. Again, what is going to be formed? Block mountain, block mountain, and rift valley, and rift valley. Is it okay? Block mountain and rift valley. So this is what normal fault. So here the movement of both the block is taking place opposite to each other. So the movement is in opposite direction. Fine. So here it is due to tensional force. Let's talk about reverse fault. A reverse fault is also called as compressional fault. Second one is reverse fault. Reverse fault, it is due to compressional force. So it is due to compressional force. So here the compression is there. And this is the fault line that develops. And along the fault line, the movement takes place. This is block A, here it is block B. And this is the meeting point. Try to see the meeting point, and the outcome is like this. So this is the block A, like this, and here it is the block B, block B. So this is A, here it is B. Try to see the meeting point was here. And now both are coming closer to this. So the block A and block B is moving towards each other. Again, we happen to see the Graben, the Rift Valley, as well as Horst. But here the fault is called as reverse fault, or it is also called as compressional fault. Compressional fault. Compressional fault. Again, reverse fault. This is also called as thrust fault. Thrust fault. Try to see both the blocks are moving towards each other. Moving towards each other. That's why it is thrust fault. Okay, thrust fault and reverse fault. So compressional fault as well as thrust fault. Fine. Next one is, third one is strike slip fault. Strike slip fault. Strike slip fault, that is also called as lateral fault. Lateral fault. So when there is horizontal movement, so you will find that there is a vertical upward and downward movement in this case. Suppose that here downward movement have taken place, it may be upward movement also. So here vertical movement is taking place along the fault line, but along the fault line, there is horizontal movement that takes place. Suppose that these are the two blocks and they are neither moving towards each other nor moving away from each other. Rather, there is a movement which is horizontal in nature. So what happened? पानी लेते आएंगे, पानी खत्म. There is horizontal movement of this block. Suppose that this moves forward. So you'll find that there is a movement of block. Let's say this block goes up over here. So it is but obvious. This part will be the graben. ये part क्या होगा बच्चे? This is graben. Horizontal movement है. And here it will be the horst. This part will be elevated. So it become horst. So here we will see that strike slip fault, or we can say lateral fault. Lateral fault or strike slip fault. And sometimes it is also referred as transform fault. Transform. Basically, transform fault occurs in between plates also. So plates are also of having such transform fault. Along transform fault, we happen to have lot of friction. And due to friction, catastrophic earthquake can be seen. Catastrophic earthquake. Catastrophic earthquake. Transform fault. Next one is step fault. Step. अब step fault में क्या हुआ बच्चे? जैसे मान लो this is a entire crust, and there are many fault that has developed like this because of, obviously it is normal fault. So many fault has been developed. And along this fault line, there is differential movement. It's not like the movement is in each block, the movement is same. But yes, there is differential movement. And in this way, the movement takes place like this. Suppose that this is the block which happened to have this kind of movement. Another block is moving like this. Another block is moving like this. Another block is moving like this. Fine. So this is the block. Here, this is the block. And this is the block. So you'll find that this is horst. And for this very horst, this is gravel. So this is horst H1, this is gravel G1. This is horst H2 for gravel G2. This is horst G3, H3 for gravel G3. And this G3 gravel is going to be H4 horst for G4 gravel. So you can see that there is a stepwise fault that develops. And such kind of horst graben results formation of a ramp valley. Formation of a ramp valley. So in this case, we call it a ramp valley. So it's not a rift valley, rather collectively it is called as ramp valley. Okay. When series of faults are there, when series of normal faults are there, we happen to have this ramp valley. So for example, if you see the Brahmaputra river, Brahmaputra river, especially in Assam Valley, Assam, lower Assam, it is forming ramp valley. It flows through a ramp valley. You will find there is a ramp valley develops in Assam from the find Rift Valley. And there are so many examples of Rift Valley and graben. As we have discussed earlier also. For example, we have Rhine Mass, Rift Valley. Already हम लोग discuss कर चुके हैं. So Rhine Mass, if you remember, first Rift Valley and Horst, there is Rhine River. Rhine River is a Rift Valley river. And there is Vosges and Black Forest. Black Forest. Then another example we have second East African Rift Valley. East African Rift Valley. So it is the largest rift valley of the world. It is almost 4,800 kilometers, starting from Jordan River, okay, starting from Jordan River Valley through Red Sea, entering in Africa, through Red Sea, entering in Africa, and up to Zambezi. Zambezi is a river. Zambezi Valley. So you'll find it up to Zimbabwe. Fine, Zambezi. It's almost 4,800 kilometers. So this is East African Rift Valley. So if you see East African Rift Valley, you'll find it is almost here it is Sinai Peninsula. This is Red Sea. So let me draw the Rift Valley starting from Jordan River. Jordan River enters through Red Sea. You will find this Rift Valley like this. So this is what East African Rift Valley. You will find a lot of lakes over there. Lakes are there. Volcanic eruptions are there. And it covers almost 4,800 kilometers. So East African Rift Valley. So rift is developing because of faulting taking place over here. And similar example, you will find Death Valley in California. Third example, Death Valley. California, USA. One of the hottest place in the world. And it is also the lowest place in North America. Death Valley. It is the hottest place. Death Valley. Another example of Rift Valley is what? Dead Sea. Dead Sea, which is the lowest point lowest point on the earth. Lowest point on the earth. It is 867 meter deep from mean sea level. Average mean sea level. Okay. Then we have in India, we have Narmada Rift Valley, Narmada Rift Valley. Then we have Tapti Rift Valley. Narmada Rift Valley, Tapti Rift Valley, Damodar Rift Valley, Damodar Rift Valley. Son River is also flowing through Rift Valley. So please take down Son Rift Valley. Okay. Fine. So these are the Rift Valley and Horst. ठीक है बच्चे. So these are few Rift Valley and Horst, which is because of tensional force. Fine. Let's come to the exogenetic force. Exogenetic force, that is weathering, erosion, transportation, and deposition. These all are taking place, which is responsible for denudation process. Denudation process. So whatever the first and second order landform created on the Earth's surface, exogenetic forces are doing what? Weathering, erosion, transportation, deposition of sediment, and clear the land, and which is called as denudation process. Let's take up one by one. First one is weathering. Weathering. समझ में आ रहा है बच्चे? किसी को कोई दिक्कत तो नहीं? Everyone is syncing with the notes, understanding the process. उधर फॉल्ट बताया, उसमें कोई दिक्कत नहीं. नॉर्मल फॉल्ट सिंपली क्या होगा बच्चे? दोनों एक दूसरे से दूर चले जाएंगे. टेंशनल फॉल्ट है, कंप्रेशनल फॉल्ट में क्या होते हैं? दोनों ब्लॉक पास पास आ जाते हैं. दैट इज रिवर्स फॉल्ट, कंप्रेशनल फॉल्ट. ठीक है. And then strike slip fault, when there is a horizontal movement. Suppose that this is one block and this is another block. Fine. अब जैसे मान लो कि this block comes horizontally forward. So try to see the difference over here. इस वाले ब्लॉक के ठीक सामने रिफ्ट वैली बन जाएगी, and this is what the horst for the rift valley, and this is what strike slip fault. So there is a horizontal movement, strike slip fault develops, or it is also called as transform. Understood? कोई दिक्कत तो नहीं किसी को?
सर वो
Yes,
एक
sir.
बार और बताइए
क्या चीज?
सर. स्ट्राइक स्लिप फॉल्ट.
स्ट्राइक स्लिप फॉल्ट. यहाँ ध्यान से देखिए, मेरे हाथ में दो ब्लॉक्स हैं, है ना? दोनों ब्लॉक है. ठीक बच्चे? अब साइड से देखो, जैसे जो मेरी तरफ जो ब्लॉक है वो आगे निकल जाए, है ना? तो ध्यान से देखो, तो यहाँ पे रिफ्ट वैली बनी कि नहीं जहां मेरी उंगली है? बोलो. और ये ऊंचाई जो रहेगी वो उसका ब्लॉक माउंटेन होगा. सो देर इज अ हॉरिजॉन्टल मूवमेंट इन द ब्लॉक. लैंड ब्लॉक गेट हॉरिजॉन्टली मूव्ड. और वहां क्या हो रहा था? इधर इट इज मूविंग अवे or it is moving towards, isn't it? So there was a normal fault when moving away, है ना, टेंशनल फॉल्ट. और यहाँ क्या होगा? सिंपल हॉरिजॉन्टल मूवमेंट है. देयर इज नो वर्टिकल मूवमेंट. इज इट ओके?
ओके सर, ओके सर।
ऐसे देखो, दो बिस्किट रखे हो ना प्लेट में, तो एक बिस्किट को सरका के थोड़ा आगे कर दो, तो दोनों बिस्किट के बीच में स्ट्राइक स्लिप फॉल्ट बनेगा. जो बिस्किट आगे हो जाएगा वो प्लेट से ऊंचा होगा कि नहीं? बोलो. सो जो बीच
यस
में
सर।
जगह बनी है प्लेट और आगे निकली हुई बिस्किट के बीच में, वो हो जाएगी रिफ्ट वैली. और जो बिस्किट की ऊंचाई है वो क्या हो जाएगी? हॉर्स्ट हो जाएगी या ब्लॉक माउंटेन हो जाएगी. एंड दिस हॉरिजॉन्टल मूवमेंट इज कॉल्ड एज स्ट्राइक स्लिप फॉल्ट. इज इट ओके?
ओके सर।
चलिए, हम लोग बात कर रहे हैं वेदरिंग और इरोजन की. वेदरिंग क्या है बच्चे? सो दिस इज द रॉक. फाइन. And this rock is maybe igneous and it was originated over here. This is the place of birth also of this rock. Place of birth. यहीं पे ये रॉक पैदा हुई. अब इस रॉक के आते ही इसको एक्सोजेनिक फोर्स क्या कहेंगे? They start disintegrating it. These are exogenic forces. They disintegrate it and it turns into numerous fine sediment. Okay, so these are the sediment. These sediments are formed because of disintegration of this rock. And here it is in situ disintegration. In situ disintegration. In situ breakdown or static breakdown of the rock. Static breakdown of the rock is called as withering. Static breakdown of the rock is called as withering. Static breakdown. जहां पे ये रॉक पैदा हुई वहीं पे इसको किसमें तोड़ दिया गया? सेडिमेंट में. तो उसे क्या कहते हैं बच्चे? वेदरिंग. एंड व्हाट अबाउट इरोजन? Dynamic disintegration is called as erosion. Erosion, suppose that this rock is moving. This rock is moving under the influence of certain erosional agent, maybe water, maybe glacier, maybe wave. And this rock is moving, so it is but obvious that there will be friction generated between bedrock and the moving rock. This is the moving rock. And due to this friction, what happened? Disintegration of both the rocks taking place. So यहाँ पे disintegration हो रहा है बच्चे, लेकिन कैसा disintegration है? There is dynamic disintegration. And such friction in the parent rock and moving rock is called as abrasion. Such friction is called as abrasion or corrosion. Fine. So the friction between bedrock, here it is called as erosion. So dynamic disintegration, please take down, dynamic disintegration of the rock. Of the rock is called as weathering. Oh, sorry, it's called as erosion. Dynamic disintegration is called as erosion. When the rock is moving, it is in direct contact with bedrock near the interface friction develops between moving rock and bedrock that results disintegration. The process is called as abrasion or corrosion. So abrasion या corrosion कब होगा? जब बेड रॉक से मूविंग रॉक कंटिन्यूअस फ्रिक्शन में होगी और टूट फूट होगा, so that is what called as abrasion, and that is what type of erosion. And suppose that the rocks are moving and the rocks are colliding with each other. So this moving rock are not only moving, but they are colliding with each other. So due to collision, there will be friction that is generated over here. And due to this collision, there will be breakdown. So this is a dynamic disintegration, erosion, and here this erosion is called as attrition. This is what called as attrition. Okay. So when moving rocks colliding with each other, it results disintegration. It results disintegration of the rocks. And the process is called as attrition. The process is called as attrition. So attrition, abrasion, fine. Let's take up weathering in detail. So different types of it. Okay. Types of weathering. Let's take up one by one. Weathering on the basis of different agent involved. On the basis of agents, we can divide weathering into three groups. One is mechanical weathering. That is also called as physical weathering. weathering. Then there is chemical weathering. Chemical weathering. Who is going to do chemical weathering? Certain chemical agent, certain chemical reaction is involved. And third one is biological weathering. Weathering, or there is biochemical weathering. Biochemical weathering. So biological weathering or biochemical weathering. Let's take up one by one. So first one is physical weathering, and there are physical agents. Physical weathering or mechanical weathering. Physical disintegration of rock. Physical disintegration of rock, that is what physical weathering. And the agents involved, the agents are number one, water. It will be in form of moisture also, or it will be in form of frost or ice. We have third, insolation, or you can say heat, or synonymous is going to be temperature, but it's not a synonym. Heat is a form of energy and temperature is degree of hotness and coldness. And fourth physical agent is wind. That is also going to cause weathering. And wave and glacier, they are also the agent of disintegration, but they are going to cause erosion. Fine. So physical disintegration or physical weathering is performed by these, what you can say, agents. These are the agents, physical agents. And some example of physical weathering is block disintegration due to temperature change. First one is block disintegration. Block disintegration due to change in temperature. Okay. So there are some rock which is affected by the change in temperature. Fine. There are some rock material which is affected by what you can say, change in temperature. So there will be thermal expansion, when there is high temperature. So obviously inside the rock, there will be some metal that get thermally expanded at high temperature. At low temperature, there will be thermal contraction, thermal contraction. And repeated thermal expansion and thermal contraction will create loosely held zone. From where the block get loosely held and disintegrate. Fine. And this is how the rock get broken. Okay. The rock get broken. Fine. So block disintegration. Next one is granular disintegration. Granular disintegration. So the rock is made up of different different color of grain, different grain, or you can say crystal, having different composition, having different composition and color. And due to different composition and color, they absorb different amount of insolation. Different amount of insolation. Insolation. And it is but obvious because of different amount of insolation absorbed by the rock, there will be thermal expansion. There will be more thermal expansion, less thermal expansion. So there will be differential thermal expansion. And there will be differential thermal contraction. So due to this differential absorption of heat, there is granular rock get disintegrated in different grains. So rock get disintegrated in different fragment. Rock get fragmented. Okay. There is third frost action. Frost action. So block disintegration through frost action. Here block disintegration through granular disintegration. Frost action कैसे काम करता है बच्चे? Suppose that this is a rock and here there is a crack inside the rock. And this rock is present in an area where the day temperature is above 0 degree. 0 degree centigrade. And the night temperature below 0 degree centigrade. Okay. So day temperature above 0 degree centigrade, night temperature is below 0 degree centigrade. तो दिन में क्या होगा बच्चे? इस क्रैक और क्रिवासेस में पानी लिक्विड स्टेट में होगा. दिस इज लिक्विड वाटर. लेकिन जैसे ही रात होगी, दिस लिक्विड वाटर गेट फ्रोजन इनटू आइस. और जब ये आइस में बदलेगा बच्चे, सो इट एक्सर्ट मैसिव प्रेशर टू द सराउंडिंग. रॉक के ऊपर बहुत सारा प्रेशर एक्सर्ट करेगा, है ना? क्योंकि आपको पता है कि when water get frozen, its volume get increased. पानी जब जमता है बच्चे, so when water get frozen, become ice, volume get increased. वॉल्यूम बढ़ जाता है बच्चे, ये बात पता है ना? वॉल्यूम इंक्रीज्ड. ये एनॉमलस बिहेवियर ऑफ वाटर है कि जब वाटर लिक्विड स्टेट से सॉलिड स्टेट में जाता है, बाकी जगह आप देखोगे अदर मटेरियल undergoing solidification or you can say condensation, then the volume get decreased, but in case of water it get increased as it traps air in the close packing of ice. तभी आप देखते होंगे आइस इज लाइटर देन द वाटर. व्हेन यू ड्रॉप द आइस क्यूब इन वाटर इट फ्लोट्स. फाइन. क्योंकि इसका वॉल्यूम ज्यादा होता है, सेम मास एज मोर वॉल्यूम, दैट्स व्हाई डेंसिटी इज लेस. तो यहाँ बच्चे दिस फ्रोजन वाटर एक्सर्ट मैसिव प्रेशर, जिससे ये रॉक के क्रैक और बड़े हो जाएंगे. सो दिस क्रैक विल बी बिगर. नेक्स्ट डे देयर विल बी मोर वाटर, अगेन फ्रॉस्ट and there is a thaw, frost and thaw. This will continues to be there, and one day these two rock blocks get disintegrated. So there is a repeated freeze and thaw. thaw हो जाने के बाद फिर से लिक्विड बना बच्चे, और फ्रीज होने पे वॉल्यूम बढ़ा और पानी आया. सो रिपीटेड फ्रीज एंड थॉ increase the crack, increase the crack, and the rock get disintegrated, get broken. अच्छा, आपको क्या लगता है only one crack is there in the rock? There are several such cracks are there. So due to fridge and thaw, what happened? There is disintegration. Fine. And there are many such process. For example, there is another process that is called as exfoliation. Exfoliation because of change in temperature. Change in temperature. So let's consider the area which is a desert. So in desert area, suppose that this is the rock. In desert area, days are hotter. So we happen to have 45 degrees centigrade temperature, and the nights are colder. Let's say 20 degrees centigrade temperature. So cold night occurs in desert and hot days are there in desert. So दिन के समय में क्या होगा बच्चे? ये rock, there will be thermal expansion. ये rock का जो ऊपर का part होगा exposed है ना बच्चे heat को. So there will be thermal expansion. And at night there will be thermal contraction. Thermal contraction. So there is one day thermal expansion, thermal contraction. और क्या होगा बच्चे? This rock upper layer get loosely held, and one day there is exfoliation of this rock. So the rock upper layer get detached from the rock. Get detached from the rock. This is the upper layer of the rock that get detached. And further it is disintegrated in various fragments. Again, the remaining rock is going to be exposed to the same high and low temperature. And in this way, the rock become onion type weathering. This is also called as onion type weathering, where the disintegration taking place layer by layer. Layer by layer disintegration. Okay. And this is what we call exfoliation due to change in temperature. Exfoliation due to change in temperature. Okay. Exfoliation due to change in temperature. Next one is there is a rock. Suppose that this is the rocks. Fine. These are the rocks. Bedrock. और इसके ऊपर एक बड़ी रॉक रही होगी, and because of certain action this big rock removed from here. Removed. Maybe ये mountain हो और ये along the slope ये move कर गया हो. So this is the rock which is left over, the bedrock. So what happened? Due to release of load, the lower rocks get expanded. this create more cracks and joints. More cracks and joints. And due to this unloading, here removed or unloading, this is also called as unloading. There is reduction in the load and the bedrock expands. This create more cracks and joint. Okay. And later on, they get loosely held because of other activity and removal of layer takes place. Fine. In form of sheeting. You will find sheeting is going on. Spalling is going on. And sheeting and spalling leads to block disintegration. Block disintegration. So here block disintegration have taken place because of release of pressure, because of release of load, unloading. Okay. What is sheeting? When the cracks are developed parallel with the crustal rocks. Suppose that these are the crustal rocks. Okay. And sheeting refers to development of crack and fracture parallel to the ground surface. Sheeting refers to development of cracks and fractures parallel to the ground surface, parallel to the ground surface, parallel to the ground surface, caused by removal of overlying pressure, removal of overlying pressure. Fine. Sheeting. Okay. Sheeting. And later on, these fracture is going to be the point of release of this point of uh, disintegration of the rock. Is it fine? And there are many other types of physical weathering, but these are some main type of physical weathering where the physical agents are active. Let's talk about chemical weathering. Chemical weathering. And this involves chemical reaction. Chemical reaction. And there are three main agents for chemical reaction. And the first one is water. Second one is oxygen. And the third one is carbon dioxide. Okay. So let's take up water. So water goes for various chemical reaction. And the first reaction is solution. Solution. So in the rock, if there will be any soluble mineral, it will be dissolved in water. Dissolved in water. And this will create weak zone in the rock. तो मान लीजिए यहाँ पे ये जो मिनरल थे, ये वाले, ये सारे क्या थे? सॉल्युबल थे. अब यहाँ से पानी गया और इसको डिसॉल्व किया तो ये दोनों रॉक टूट के अलग हो जाएंगे. So this will create weak zone or fracture zone from where the rocks get detached. And the minerals like carbonate minerals, carbonates of calcium, magnesium, sodium, potassium, chloride, oxides of these elements. These all are sulfate, even sulfate of these elements are readily soluble in water. Okay. फॉर एग्जाम्पल लाइमस्टोन बना हो, डोलोमाइट का बना हो, तो वहां पे जल्दी से घुल जाते हैं बच्चे, एंड देन देयर इज सॉल्यूशन. So we have the solution. Fine. Solution. And we'll find this solution taking place in area of rocks where means carbonate, that is limestone and dolomite. Dolomites are abundant. Limestone, dolomites are abundant. Here the process of solution is going to carve out a special type of topography. Special topography. Special topography that is called as karst topography. Karst topography. Where the surface water as well as groundwater, surface water and groundwater become the active agent, or the active agent, and they are doing nothing but solution, and peculiar type of topography develops. We will discuss in karst topography. Fine. Karst topography. Next one is hydration. Hydration. So there are some mineral which is not soluble, some mineral not soluble in water, but they can absorb water. है ना बच्चे? अब जैसे ये rock, this rock has this particular zone which is containing mineral which is not soluble. Soluble तो नहीं है, लेकिन अगर पानी आ गया तो पानी को ये क्या कर लेंगे? They absorb water. तो अगर ये absorb कर लेंगे बच्चे, तो जाहिर सी बात है this will create a weak zone over here. So there will be a weak zone created. Weak zone. Along this weak zone, this rock gets disintegrated. So this process is called as absorption, hydration. So water get absorbed in this mineral and it create weak zone over there. है ना? जैसे there is feldspar. Feldspar. It is not soluble, but it absorbs water. Feldspar absorbs water and get converted into smoother mineral that is called as kaolinite. 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 Okay. So there is hydration. Okay. There is a process, hydrolysis. In which what happens? Loss of water from certain mineral decreases the strength of cementation. Strength of cementation. And most affected mineral are silicate. Most affected minerals are silicate. Silicates. So because of loss of water, silicates are loosely held and they get fragmented. Okay. For example, MgSiO2, magnesium silicate. And when hydrolysis is done, that means water removed, it will be converted into MgOH whole twice. That is what magnesium hydroxide. And magnesium hydroxide plus H4SiO4. H4SiO4 is silicic acid. Silicic acid. Fine. So there is change in the moiety. The silicate get hydroxide. There is a magnesium hydroxide. And not only magnesium hydroxide, there is formation of silicic acid, and it will further dissolve other minerals. So this acid will dissolve other minerals. So hydrolysis is also one of the process in which there is disintegration of rock. Another one is oxidation. Oxidation. Suppose that certain mineral like iron and aluminium, they are stub-bond. Stub-bond. They are neither dissolved in water nor going to get hydrated. So along with oxygen, water will do what? Oxidation of these mineral and formation of oxides takes place. Oxides. And these oxides are in powder form, in rust form, and it can easily be removed. Easily removed oxide. So when you will find more rusting taking place in the rainy season, you will find more rust taking place on iron. So because of easily removable oxide, which is removed by splash of the water, it can be removed by wind, and slowly and gradually the iron and aluminium stub-bond mineral get disintegrated, and that will lead to further disintegration, and the process is called as oxidation. Another process is called as carbonation. Carbonation, in which water reacts with carbon dioxide and forms carbonic acid. It forms carbonic acid. Carbonic acid. Fine. And this carbonic acid is what changes different, what you can say, insoluble in water, insoluble mineral in water are readily soluble. Readily soluble in acid. Readily soluble in acid. Fine. Fine. And now what happened? Not only this, it changes calcium carbonate as well as magnesium carbonate. These are the limestone and dolomites. In presence of carbonic acid, they are going to change into their bicarbonates. Bicarbonates. And these bicarbonates are easily soluble. Easily soluble in water. So it will increase the rate of erosion because of formation of carbonic acid. Who is going to form carbonic acid? Water reacting with carbon dioxide. So this is what chemical weathering. And the last one is biological weathering. And you can better understand. There are certain biological animal as well as plants. They are doing this weathering. For example, rodents are there, burrowing animals are there, earthworm is there, termites are there, ants are there, we human beings are there. We are continuously doing mining activity, agriculture and all. So we are also doing this disintegration of rock. Not only this, microbes, they are tirelessly doing the process of decomposition, which is also responsible for formation of different types of acid in soil, and this acid lead to different type of chemical reaction. So there is biochemical weathering also. What about big trees? Big trees are having strong root system, and the roots are penetrating the parent rock. These roots are penetrating the parent rock. The parent rock, and creating more cracks and joints, है ना? So parent rock के अंदर more cracks and joints. And through which other agents are going inside, or it will perform weathering. So this is what biological weathering or biotic weathering or biochemical weathering. It includes fungal weathering, anthropogenic weathering, floral weathering. We have this faunal weathering. So all these type of biochemical weathering can be there. Is it okay to everyone? So this is the
Yes,
types
sir.
of. हाँ, क्या बोला बच्चे?
Nothing, sir. Just it's okay, I said.
Okay, fine. मुझे लगा आप कुछ पूछ रहे हैं. सो आज वेदरिंग कर लिया हम लोग. कल हम लोग इरोजन और मास मूवमेंट करेंगे, और कल क्लास नहीं रहेगी बच्चे. कल मुझे यात्रा करनी है, तो 4 तारीख को हम लोग मेरे मिलेंगे, 4 फिर 5 को छुट्टी रहेगी, 5 को फिर मुझे यात्रा करनी है. फिर 6 सितंबर ऑनवर्ड्स वी आर गोइंग टू मीट एट द सेम टाइम, और फिर हम लोग कंटिन्यूअस क्लास करेंगे. अगले 1 महीने तक क्लास विल बी ऑलमोस्ट कंटिन्यू, लिविंग संडे में भी एक आध दिन और छुट्टी मिल जाएगी. लेकिन यहाँ 6 सितंबर से हम लोग क्लास लगातार करेंगे. यहाँ कल क्लास नहीं होगी, कल 3 तारीख है, कल मेरी जर्नी रहेगी. तो और फिर 5 को जर्नी अगली रहेगी. तो 4 को शाम को हम लोग मिल लेंगे, तो उस दिन इरोजन वाला पार्ट कर लेंगे, फिर लैंडस्लाइड और आगे की कहानी फिर आगे करेंगे, एंड देन इरोजन साइकिल, डेविस पिंक और इन सबको ध्यान से देखते हुए आगे बढ़ेंगे. इज इट ओके टू एवरीवन?
यस
ठीक है बच्चे, फिर
सर,
रखते हैं.
सर पीडीएफ शेयर कर
हाँ, आज शेयर कर दूंगा मैं कल.
दीजिए. थैंक यू सर.
अच्छा, कभी ऐसा हो, मेरा नंबर आप लोग के पास है कि नहीं? मुझे एक व्हाट्सएप मैसेज छोड़ दिया करें या टेलीग्राम पे ही कि सर नोट्स शेयर कर दें. असल में क्लासेस लगातार होती हैं ना, तो कभी कभी मैं मिस कर जाता हूँ, बिल्कुल ब्लैंक होता हूँ, और आके फिर याद आता है कि नहीं भेजा. तो शाम को मैं देखा तो मैं भेज देता हूँ, अभी मैं तुरंत भेज दूंगा, ठीक है?
ओके सर.
और मैं
थैंक यू.
अपलोड कर देता हूँ वहाँ पे वीडियो, तो वहां से आप देख लिया करिए, ठीक है? फिलहाल अभी हम लोग ऐप पे नहीं कर रहे हैं, सीधे वहीं कर दे रहे हैं वीडियो अपलोड। लेकिन फिर कुछ दिन में ये रेगुलर हो जाएंगे तो हम लोग ऐप पे इसको वीडियो को अपलोड कर देंगे, जहां से आपको एक्सेस दे दिया जाएगा, यू विल गेट द वीडियो फ्रॉम देयर। ठीक है बच्चे, सो थैंक यू वेरी मच फॉर टुडे।